Thank you all very much for coming. My name's Alastair Smith. You can find me on Twitter as Alastair S, and I'm here to talk to you about software craftsmanship for startups. Software craftsmanship is an idea that has been kind of something that has stuck with me for most of my career now. Actually, I've been a software craftsman since around about 2010, and in 2012 I founded the Cambridge Software Craftsmanship community as well in the UK. However, most of my industry experience has been in sort of larger companies or companies that are maintaining existing products, legacy code bases, etc., etc. And 9 months ago I joined a very small company called Cloud Hub 360, which is a Cambridge-based startup. And this was my first kind of real ability to apply the software craftsmanship principles in that kind of environment, essentially. And that's what I'm here to talk to you about today. So, just before we get started, how many of you are aware of the Software Craftsmanship Slack group? A couple, okay. So you can go to slack.softwarecraftsmanship.org and sign up to the Slack team if you haven't got enough already, that is. It's a fantastic community for discussing software topics and yeah, many of the similar ideas to what you'll be exposed to in this talk and in the conference more widely as well here today. And finally, the Socrates events. I don't know how many of you have heard of those or been to those. No? Okay. They're fantastic unconference style events. They are essentially 2 days of open space, like we're having in the afternoons here, and they're full of fantastic discussions and sort of hands-on workshops, and there's a really big social element to them as well. They take place at various points throughout the year across the continent, and more sort of worldwide now as well. And so have a look at, I think it's Socrates.de for the full schedule around the continent. So let's get started. So let's first of all have a think about what software craftsmanship is. And when I've had conversations with people about software craftsmanship previously, these are some of the things that come up in discussion. They're some of the things that people equate with software craftsmanship and often confuse with software craftsmanship as well. And some of these are kind of understandable, things like TDD we talk about a lot in the software craftsmanship community. Katas and dojos we run a lot. The solid principles, for example, but then there's some slightly more unusual ones like feature branching and switches and Git and Smalltalk, for example. And over time I came to realise that actually none of this is software craftsmanship at all. This is software development and this is software practice. And some of the things on that list, such as Git and Smalltalk, are just tools, actually. Much of the practices on that slide are XP practices, TDD, continuous integration. Continuous delivery is an agile principle. It's not even anything more specific than that. It's just like a guiding light to follow during software development. So, with all that in mind, let's go back to the manifesto and find out what software craftsmanship is all about. How many of you have read this? A couple. Okay, now's your chance. So, as aspiring software craftsmen, we are raising the bar of professional software development by practicing it and helping others to learn the craft. We have come to value not only working software, but also well-crafted software. Not only responding to change, but also steadily adding value. Not only individuals and interactions, but also a community of professionals. Not only customer collaboration, but also productive partnerships. In pursuit of the items on the left, we've found the items on the right to be indispensable. So my reading of this manifesto is that it's describing a mindset more than anything else, an approach, a way of thinking about software development. It talks about the things that we value. Well-built software, incrementally adding value, community of professionals, productive partnerships. And to me, this is a sort of mindful approach to software development, a very sort of thoughtful way of carrying out the process. And there are three sort of pillars to this mindset that I think sort of form it overall. So the first of those pillars is one of being quite methodical in one's work. So for each of these, I'm going to use TDD as an analogy. So TDD is a very methodical practice. It is systematic, it is orderly. There are three stages to TDD. There's red, there's green, and there's refactor. Those steps all exist for a reason, and they exist in that particular order for a reason. So we can say that it is systematic. It is an overall system for developing code, but it's also orderly. Sorry, the order of the steps matters. It is deliberate. Every step in TDD has a purpose. The purpose of the red step is to identify the next piece of functionality that we are going to build. The green step's purpose is to actually implement that functionality. And the refactor step is to do the design of that work. Because remember, the green step, we only do the most naive implementation we can manage to get the test to pass. During refactoring, we do the design to make it correct, to make it cleaner. And these are in this order because you can't write new code if you've got failing tests. If you've got failing tests, you don't know if the system is currently working, or if the change that you've just made has broken something else in addition to what's already broken. We can't refactor before we get it working because we want to stick to the principle of make it work and then make it right. So as I say, it's both a very methodical process and a very deliberate process. And finally, the last aspect of the mindset of software craftsmanship that I think matters is one of considering your approach. So someone that I used to work with in my previous job had a really good way of making us think about the approaches that we were taking, sort of forcing us to consider what we were doing. And so any time that you kind of came up with an idea for a sort of particularly large refactoring or redesign, or an implementation approach that you wanted to take, for example, it would be a case of asking yourself, well, what alternatives have you considered? Have you come up with other designs and then dismissed them, or is this the one that you have that you've thought of first and then just kind of run with it? What is good about this design versus other ones that may or may not work? So it's something that you've thought about. It's something that is defensible when challenged by someone else, that you can sort of justify to other people if you need to. So as I say, this all adds up to a very sort of mindful approach to software development, and I think of this as the very opposite of mindlessness. So it's not a case of being a sort of code monkey in an organisation and just sort of hammering out lines of code to meet a specification that's been decided by someone else 3 offices down the road or something. It is a case of being an actively engaged participant in the process. Thinking and considering what you're doing and why you're doing it, essentially. And the thing that this really, the benefit that this really brings, as far as I'm concerned, is opportunities to learn from your own past experience and also the experiences of the wider industry as well. Being open to conferences like this where you can learn from other people and yeah, pick up new ideas and have your own kind of principles and practices challenged. And I don't mean that in a sort of negative way. It's more about having curiosity about what else is out there, about how we can improve and be better, rather than being sort of self-doubting and questioning and that sort of thing. So overall, I think this really reflects an idea of pragmatism, and this is the thing that software craftsmanship is to me. It is a pragmatic approach. It is with the mindful attitude that I've just described, I think we have a better mindset to be pragmatic in our work. The choices that we make, the decisions that we have to stick with, because we have considered them, we've applied methodical processes to come up with those decisions. And again, thinking about this in terms of opposites, it is the opposite of dogmatism. So if we think about a very kind of dogmatic approach, it is we must do this because this is the way it's always been done. This is the right way to do it. This is best practice, etc. It's pragmatism is much more about bending your approach to fit the situation that you are currently in and not applying the same approach to every situation. So, what about startups then? Startups are very fast-moving environments. There is rapid rates of change in startup environments, and as a result they are often very highly pressured environments. There can be a lot of pressure to cut corners, for example, or to maybe abandon some of the principles that you've otherwise found useful to get something out of the door faster, essentially. And a lot of this comes down to the fact that speed of delivery is king in startups. We will be dead in 3 months if we don't ship this product. We won't have jobs anymore, etc. So what's the point in building it right if we're not building the right thing even, or if we're going to throw it away in a pivot in 3 weeks' time? What's the point in investing that time? And these are sort of some of the common criticisms of software craftsmanship in a sort of startup-like environment. What is the point of applying these principles and practices? And for me it comes back to the speed of delivery. If speed of delivery is king, then surely we should be optimizing for speed of delivery, not kind of throwing away the things that we find valuable and sort of just hacking anything together to ensure that we get it ready, get it shipped. Do we not then end up running the risk of slowing down our rate of delivery in a week or two's time, or maybe even a couple of days' time, because we've made a decision in an unmethodical or slightly careless way, perhaps? So this links back to the Software Craftsmanship Manifesto that we saw earlier. Optimizing for the speed of delivery, for me, means investing in well-built software and adding value incrementally and steadily. The way to optimize for speed of delivery is to remove impediments to delivery. So it's things like easy reusable automated builds, easy reusable automated tests, and easy reusable automated deployments. It's about making this so common and so usual that you don't have to think about it anymore. Incremental delivery, as I say, is one of the things that is mentioned explicitly in the manifesto, the Craftsmanship Manifesto. It is all about delivering in small chunks, and the reason that we do this is because it is faster than large chunks. You can get something small built much more quickly than you can get something large built. You can get it deployed much more quickly. The more you break stuff down, the more you are able to get through the backlog more quickly. It gives you much faster feedback as well. There is a much tighter feedback loop around a small slice of a feature that you can ship in a couple of days versus getting the full fat version of the feature done in 2 weeks. And small chunks are usually more disposable as well. If the business is going to pivot in 3 weeks' time, or if it might pivot in 3 weeks' time, then we want to make this code as disposable as possible, because we may not even need it anymore. It may be that we want to keep parts of what we've written, but not other parts. So we need the structure in there available so that we can achieve that quite easily. Above all else, though, delivery helps discover other requirements. The number of times over the last sort of 6 months or so where we have built something over a slightly longer time period than we wanted and ended up discovering things later in the process as we were going through the deployment and the making live part of the process, the more we found that actually we should have done that a lot earlier and found that out more quickly so that we could learn from that and factor it back into the design. If delivery helps discover other requirements, then surely we should be delivering as much as humanly possible so that we get the requirements as early as we can. So, I'm going to talk through some of the principles from the manifesto in a bit more detail, and I might have to skip over some of them in a little bit of time. But yeah, we'll start off with well-crafted software. I love prototypes. I have found them so useful in the last few months because they're like building a representative example of the full application, a simulation or a model, if you like. There's always lots left out, but that's done quite deliberately, so that you have just enough of the product built to demonstrate the value that it is going to bring. The one piece of advice that I can give you about prototypes is to absolutely always throw it away at the end. I have done 2 prototypes in the last 12 to 18 months or thereabouts, and the first one we threw away and the second one we didn't. So the first one was at my previous company. We were doing some new product development and we were trying to build up a new tool to make changes to people's reference data in their database, the things that don't change across deployment. So like lookup tables of country names, for example, or exchange rates, that sort of thing, that don't really change that much over time. And the prototype that we built was good enough to demonstrate that we could do this, that it was something that was going to work. It proved the concept nicely. We showed it to a few friendly customers. They loved it. They wanted it. That was great. We then threw away that prototype because we knew that it had been written without much thought given to things like error handling, for example. And when you're writing data to people's databases and potentially dropping rows in people's tables, you really want to know that it's built solidly. So we decided to throw away that bit of the prototype because it wasn't built as well as we needed it to be. And we rewrote it, and we used TDD and more detailed specifications and all the rest of it to ensure that that bit was going to be robust and it wasn't going to destroy people's databases. At the other end of the scale, the company that I'm currently working in, we built a prototype at the start of the year. And that one was built in a sort of microservices-based approach, which sort of fooled us into thinking that there was not much code there, because each component was very small and very focused, and we could just throw it away and rewrite it as we went along. We didn't do that. we ended up doing the classic thing of getting more sort of sidetracked by adding new features to the prototype and working elsewhere. When in reality, given how much code there actually was there, a week or 2 weeks worth of rework to make that a bit more robust would have then left us in a better place to carry on development of it now. Sometimes, however, as was the case with this more recent prototype, you simply can't write tests first. You might be in the situation, for example, where you have second-order unknowns, as Dan North likes to call them. Essentially, you don't know what you don't know. You don't know where your ignorance lies. And in my opinion, I don't think TDD works very well in that kind of scenario, because it's a very exploratory technique that helps you kind of home in on particular parts of the specification or the application. If you don't really know what the space is that you're working in, how are you able to explore it effectively when you don't know which way is up and which way is left, for example? However, in my opinion, if you are going to take this approach of sort of building out a prototype and then stabilizing it later, you need a very highly skilled team to do that, because you need to write tests for existing code. And we have a name for code that has no tests. It's called legacy code. So proper prototyping, in my opinion, where you build something and then throw it away at the end, is easier. It just gives you that much more flexibility, and it's easier because you've already solved the problem. There's this idea of a wicked problem, which is a problem that gets easier each time you solve it, but is really hard to kind of understand without attempting to solve it. So your first prototype is great because it gives you information about how to solve the problem, but invariably you won't have gone about solving that in the most efficient or effective way. You can then use the knowledge that you gain from that prototype to plough it into the next version of that build. Also, under well-crafted software, we have product design. And I want to talk about this from a couple of angles. So we have architecture and we have UX. So architecture is a bit of a tricky one. You can lose a lot of maneuverability in your application from too much or too little architecture. And on the flip side, good UI and good UX is pretty much expected now of any new product that hits the market. So you have to consider it as a key part of the application from the start. With architecture, the concept of kind of no architecture is essentially a fairly naive reaction to big design up front. And this approach will very quickly form a big ball of mud in the application. However, going too far the other way gives you too much architecture and is either old school big design up front, or it produces complexity in deployment and operations. However, if you can aim your architectural approach at the just enough kind of area, then you stand to gain a lot. And the way that we have achieved that in my current team is to discuss and plan the architecture without kind of overdoing it, to agree that the principles that we want to stick to, the ideas that we want to follow, but not trying to pin down every last aspect of the system. The idea overall is to leave room to flex the design of the system and to not choose an architecture that stands in the way of delivery. That is another thing that I think we went a bit wrong with on the prototype earlier in the year. In choosing the microservices model, we ended up with all of the complexity of the microservices model, such as distributed monitoring and tracing and all the rest of it. And that sort of got in the way of building the functionality at times. So the idea here is to architect for ease of deployment and for ease of communication between different parts of the system. Do take careful aim with your code. So ultimately we want easy to change code, but we also want easy to delete code. If we've got the kind of situation where parts of the application are going to be useful elsewhere in other prototypes or other parts of the kind of business domain, then we want to throw away the extraneous bits that we don't care about so much and keep the bits that we do care about. So the reasons for focusing on easy to change code are because we have changing problems, we have changing solutions, we have a changing context, and even at times a changing business as well. So, steadily adding value. A bit of a word on MVPs, or minimum viable products. There are examples of these everywhere if you kind of open your eyes to them. I went to the Cosmonauts exhibition at the London Science Museum last year, and there was a really nice example there with the Sputnik spaceships. The question that they wanted to answer was, how do you send a person into space? Well, they started off by answering the question, how do you send anything into space? This had never been done before. And so there was a Sputnik 3. It was numbered backwards for some reason, I don't know why, but Sputnik 3 had sort of just scientific instrumentation on it. And Sputnik 1 was the first ship to send humans into space, if I remember rightly. And they got there in incremental steps. They sent scientific equipment up first, and then they sent animals, and then ultimately they sent humans. They took an incremental approach to sending people into space. Another good example is the Model T Ford. The question that Henry Ford was trying to answer was, how do you sell a car to the mass market? And his answer was the Model T Ford. It was an MVP. You could have it in any colour you wanted, provided it was black. This one, however, is quite special. This one is Salisbury Cathedral. It's one of the UK's most magnificent buildings. It has the tallest spire in the country, and it's a triumph of early English architecture and stonemasonry. Beyond that, it's built on a flipping marsh. There is a fantastic story behind how this was built, as told in The Craftsman by Richard Sennett. And the way it came about was the Lady Chapel was established first. And this was sort of constructed with a set of stone posts and beams that sort of gave the impression of a larger building to come. And over time, the treasury and the chapter house and other parts of the cathedral were added on to that. There were no blueprints, there were no architects. It was all encoded in the building itself and the way it was built along the way. It took them 3 generations to build this building, and all of that information was carried through the building of the cathedral. There were no plans at all. If people 1,000 years ago can build a cathedral without any guiding plan at all, I'm sure we can build software in a very similar way, very incrementally. This was, pun intended, a minimum viable cathedral. The way that we apply this kind of approach to software, in my mind, is using user story maps. How many of you have come across user story maps before, either as an idea or actually used them? Oh, not nearly enough of you. This is a fantastic technique. It's essentially a 2-dimensional backlog. So across the top, the second layer, blue line, we have user tasks. These are activities that the user carries out over the course of using your application. And it runs from left to right in a kind of timeline. The orange ones at the top are the activities that the user carries out, the sort of larger scale groups of functionality in the application. And then the yellow ones are the user stories, the bits that you will actually use to build out your application, the increments of functionality. And the really nice thing about this approach is that it allows you to describe the entire functionality of your feature or your application, but it also allows you to describe how to get to the full implementation of that in an incremental manner. These blue lines here describe the releases that you're going to ship. So, a more full example, imagine Gmail, for example. You can organise your email, you can write and read email, you can manage a calendar, you can manage contacts. And there are individual activities within, tasks within those activities. And in the very first release, you may, for example, want to open an email and read it. You may want to be able to write a plain text email, for example, view an appointment in the calendar, etc. The thing that I like the most in this is creating a contact here and then adding an address to the contact in release 2. But then in managing the calendar and managing the email over there, we then are able to pull in the information from the contact to apply it in the email or the appointment. So we have a staged delivery of the application and the functionality that is going to go into each of those. It's a plan, but it's a very kind of fluid plan. It's possible and should be a living kind of document on how to get from nowhere to final release at the bottom. I'm skipping over community of professionals from the manifesto because this essentially comes down to culture of the team and of the company. And it's essentially about knowledge sharing and being open and accountable. And there is not much more that I can say about that in detail than the summary that I've just given there. So I thought I'd just kind of skip it over to keep time. So productive partnerships. Work with your customers. It sounds obvious, but so many companies that I see, both startups and established companies, don't do this nearly enough. In the new product development team that I was working in about 18 months ago, we had a Slack group that we used. It was a sort of guest channel for a particular group of about 8 to 10 people that we knew were particularly proficient with the technology that we were building for. And we'd take UI designs and sort of technical decisions and all of that sort of thing directly to that Slack channel to get the input of those experts that knew that tool much better than we did to gauge their opinions and their ideas and sort of build on that. Another really good technique that a lot of startups are beginning to use now is a tool called Intercom. This is a fantastic tool that you embed into your application, and it allows you to interact with your users in real time. You might have come across it yourself in some applications where you sign up for the first time and go to the application homepage or dashboard, and it pops up a little box with a link to getting started with the application. Let me know if there's anything I can do to help, kind of thing. Yeah, as I say, it's a really useful tool. One thing that I think could work really well for this is to embed it on the error pages of your application as well. So if a user hits a 404 or a 500 error or whatever, they get the pop-up saying, I noticed you hit an error, what can I do to help, kind of thing. It's all about being very proactive in engaging with the users rather than waiting for them to come to you, etc. The last slide in this section that I have is on Lean UX. Again, this is something that we used in the new product development team, and it was so useful to us. It's described in a book that's only about 1 centimetre thick. You can probably get through it in a weekend or something. It is unfortunately a talk in itself. I can't do it justice at this point, but at its heart is the sort of plan, do, check, act cycle of incremental work. And the basic backbone of it is to identify the assumptions underlying the problem that you're tackling, the hypotheses that you will test, and forming from these the questions raised by your assumptions. The validation signals that we see here are they're like assertions in a unit test, essentially. They tell you whether your hypothesis has been proven or disproven. Finally, it's necessary to describe the feature and provide just enough design for the feature to convey the user experience, and to then test those designs with your customers or your potential customers to validate the hypotheses that you have. Yeah, if you want to know a bit more about this, I can show you the photo in a bit more detail on my laptop. I appreciate that that's not really kind of visible, probably even in front of me. Okay, so to conclude, working in a sort of new product development and startup environment in the last 12 to 18 months, I've gained a fresh appreciation for the principles behind software craftsmanship. And as I was sort of reflecting on this, I thought about examples of craftsmanship from previous eras. So, for example, when the goldsmiths of the medieval times accepted a royal commission that needed to be done in kind of 2 weeks for a festival or a wedding or something, did they abandon their principles and practices to meet that deadline? I suspect they probably didn't. Did they know their practices well enough and hold their principles strongly enough to do a good job under pressure and to apply the practices to their benefit? I suspect they probably did. And again, to quote Dan North, in a post that he wrote actually critiquing craftsmanship, he said that he expected developers to apply the appropriate amount of rigour, discipline and excellence to match the situation. And that is the pragmatism in software craftsmanship. I continue to find value in the practices that I have invested in over time and in new practices that match the principles that I have adopted and hold to heart. And I hope that you do too. Thank you very much for listening.